Good morning. We are going to do our first classwork via digital learning. So our first classwork of Unit 9, our unit on surface area and volume, we're going to talk about what 3D figures are, and I'm going to fill out the classwork notes for you. So here we go. A three-dimensional figure we call a solid. And a solid is bounded by a flat or curved surfaces that enclose a single region of space. A polyhedron polyhedra, is a solid that's bounded by polygons called faces. And remember, a polygon is that two-dimensional closed, no curve, no lines crossing shape, right? So when we talk about a polyhedron, it's going to be a solid that's bound by those flat polygon shapes that we're going to call faces. An edge is a line segment formed by intersecting faces. So you can look over at the box to the right, and you can see labeled edge, face, and vertex. And speaking of that, a vertex of a polyhedron is a point where three or more edges meet. We're going to study a couple different types, actually a few in this video. A polyhedra, when we talk about polyhedra, we're going to talk about prisms and pyramids. If you look at the calendar, we're going to do prisms first, and then we're going to do cylinders. Which are non-polyhedra. We'll do pyramids, then we'll do cones, and then we'll do spheres. So the prisms and the pyramids are made out of polygons, where cylinders and cones and spheres have curved shapes. When we talk about a prism, it's a polyhedron with two congruent parallel faces that we call bases. This is important because when we name a polygon, or not a polygon, sorry, when we name a prism, we're going to name it by its bases. So you're always looking for those two congruent sides that are parallel. They have to be parallel, and those would be your bases. And then the other faces in our parallel are going to be parallelograms. And for us, we're going to look at square or rectangular sides or faces and bases that could be any polygons. A regular prism, when we talk about a regular prism, it's going to have bases that are regular. So a square, an equilateral triangle, a regular pentagon, a regular hexagon, a regular octagon. So when we look at this example right here, you can see that the two congruent parallel bases are those pentagons. So we would name it by those pentagons. So we're going to call this a pentagonal prism. And notice that the bases are regular pentagons and the faces are rectangles. All right, so here we go. We're going to name each prism, and then we'll identify a vertex point. So this first one, rectangular prisms are kind of cool because any two opposite faces could be the bases. So that's unique to two rectangular prisms. Write that in. Prism. The next one, look at the triangle. JKL, it looks like it's an equilateral triangle. So know that we've studied a lot of triangles. We're going to have right triangle prisms. We're going to have equilateral triangle prisms. We can have scalene triangle prisms. So we're looking for that. So we're going to name this a triangular prism. And the next one we're going to call a square prism. So the question asked us to identify a vertex. D is a vertex, right? D is a vertex because it's a point where three or more edges meet. M is a vertex. R is a vertex. So we're also going to study pyramids. And when we talk about a pyramid is going to be a polygon, or sorry, a polyhedron with a base that is a polygon. And sides that are triangles. Which meet at a vertex point. Pyramids are named by their bases. So if we're going to name these pyramids, we're looking at a square pyramid. Hexagonal pyramid. And a triangular pyramid. Another shape that we're going to study is a cylinder, which has curved surfaces and two parallel bases that are congruent circles. The radius of the cylinder is the radius of one of the circular bases. The height of the cylinder is going to be the perpendicular distance between the bases and the curved surface. This is crazy. This is important too. So note this. The curved surface, sometimes we'll call it the lateral surface area. The curved surface is a rectangle. So if you were going to peel the label off a can of Campbell's soup, and you did a perfect job peeling the label off, you'd notice that it is a rectangle. Another shape we're going to study is the cone. And the cone has a circular base and a curved surface and one vertex point, as you see in the diagram to the right. The curved surface of the cone we call the lateral surface. The height of the cone is the distance from the vertex to the center of the circle. So it's like if Juan was standing right up here and dropping his little rock straight down to the center. The slant height is going to be a hypotenuse. Of a right triangle made up of the altitude, the radius, of the circle and the length from the vertex to any point on the circumference of the circle. Do you see the right triangle here? And then we're going to study spheres. And a sphere has a curved surface. Also, every point on the surface is equal distant from the center of the sphere, and that distance is called the radius. So we need to tell whether the solid's a polyhedron or not. And if it is, we're going to name it. So let's look at the first one. I know it's a pyramid, so I need to look at the base for its name. I see the base has all congruent markings, so this is a square. Pyramid. This shape can't be a polyhedron because it's got curves. So we're going to call this a half cylinder. I'm going to use this little mark I made up here. No. So remember when I was talking about triangles and triangular prisms? I see the faces are all rectangles, but none of those faces are parallel. So I need to look for the parallel bases. And when I see the parallel bases here, I see that they're triangles. In fact, they're right triangles. So this is a right triangle prism. We've got a rectangular prism here. I've got a pyramid here because I see triangle sides. I just need to look at the base, and when I look at the base, it is a hexagon, a hexagonal prism. And this is, again, a big move. This is a cone. Ready.